What's going on, guys? Welcome back to the channel. Came out to the shop the other day, looked underneath the 4Runner and saw that there is a leak coming from the transfer case. Looks like the seal around the front propeller shaft decided to give out after 20 some odd years, so can't be too surprised, I guess. So I hopped online, found a couple diagrams, figured out which seals I need. So I got those ordered. Let's take a look at what I saw. So I came out here, I saw that, and I was like, well, that's not really a good sign. It is definitely coming from that output shaft. So we will get the front drive shaft popped off, get those seals yanked out of there. If you guys are familiar at all with working on these 4Runners, you probably know who Timmy the Toolman is. Well, he's got a really awesome video on replacing the seals for the rear output shaft, but haven't found anybody covering the front, so I thought I'd put together a quick video showing how to do it. Pretty much all the same techniques and concepts apply, so definitely reference his video as well because he's got a lot of good information. Alright guys, so here's all the tools you're going to need for this job. We've got a 1/2 inch torque wrench, a 1/2 inch breaker bar, a 3/8 torque wrench, a 3/8 ratchet, a U-joint, 3/8 drive, 14 millimeter combination wrench, 1/4 inch drive ratchet with a 7 millimeter socket, 14 millimeter socket, 12 millimeter socket, 24 millimeter socket, 30 millimeter socket. You know, combination of various pry bars, brass drift, unless you've got a seal driving kit, and then a couple other steel punches. All right, step number one, it's not really required, but we're gonna do it because we're gonna wanna clean up when we're done anyway. So we're gonna remove this skid plate, and it's held on with 4 12 millimeter head bolts. So we're gonna go ahead and crack those free. We got a 12 millimeter socket on our ratchet. So those shouldn't be on there too bad. So it should just pop off, I'm guessing. Yep, bada bing, bada boom. All right, cool. Now that we've got the skid plate removed, next step is going to be removing the 4 nuts holding the front propeller shaft onto this flange. So this is a 14 millimeter nut, and we have the transfer case in 4 low, so this is not going to spin. But we don't have access to all 4 of the nuts right now. This one's hiding. So what we'll do is we'll break free as many as we can. I will put the transfer case into 2-wheel drive. We'll reclock this and we'll break free the 4th nut. Depending on what tools you have, you might be able to get a socket on here or you might not. It just depends. We'll just roll with a box end wrench. Not too bad. That's 1. Oh, I spoke too soon. There we go. And so I don't bust a knuckle, I'll go ahead and go and reclock this. So, I'll be back. Cool. All right, we just reclocked the propeller shaft, so now we've got access to the other 2 nuts. And we will break those free now. All right, now something important to mention here is before you actually remove your front propeller shaft, you need to make match marks on this knuckle, the flange on this knuckle, and the flange coming out from the transfer case. You want to make sure you get this clocked back in the same orientation to the flange, so that way you don't have any imbalance issues. So there's a couple ways to do that. One, if you have a paint marker, just make a couple match marks. That's easy. I don't have any paint markers, so I've got a punch and a hammer, and I'll just make 2 marks, 1 on each mating component, and then that way when we reinstall it, I know I'll get it back in the exact same orientation. So you want to make sure you do something like that. You don't have to worry, this isn't just going to drop off because this flange is captured by those 4 bolts. So we'll actually have to compress this in order to remove it. You don't have to kill it, but you want to make sure you have certainly a very easy to see mark. That's good. And that's good. That's all it takes. Okay. There we go. So after a lot of years being attached, might take a little persuasion to bust it free, but there's sort of a little indent here. I got a pry bar in there. Popped it and it broke it free real nice. So now hopefully we can just compress this slip yoke, but it might be a bit of a pain also. So, doesn't look like it's wanting to compress enough to get it off. So one trick that you can do is you've got these little Zerk fittings. If I break free of this Zerk fitting, it should allow the pressure that's built up inside of this slip yoke to escape, and then hopefully I can compress that a little bit easier. So I don't know what size that is. It's pretty small, probably like a 7mm or so. So I'll go grab a socket and see if we can pop that out of there. Man, I'm good. It is a 7mm. I'd recommend a socket if you can so you don't strip it. Cool. There we go. I just heard it compress a little bit more. Awesome. Cool. Alright, that's a bit of a struggle, but not too bad. So we'll just slide that out of the way. Now that we've popped off the front propeller shaft, we've got this flange, and we've got our nut holding this flange on. And right here, this nut is staked into a keyway in that shaft. So what we need to do is first unstake that. Couple options. You might have to use some sort of combination of screwdrivers and picks and hammers, and pretty much we just need to get that popped out of that keyway so we can break this nut free. And unfortunately, you don't have a lot of space to do it. Okay, we have unstaked that nut as best as I can. It's a bit of a challenge. There's not a whole lot of room to work with here. So now we need to get that nut off. And one of the best techniques to do that is if we take those nuts that were already on here, we're going to thread them back on in 2 of the locations. And we'll double up nuts on 2 of the studs. Essentially what we're doing here is we're going to be sticking a pry bar in between 2 of these studs. And if we did that just on the bare studs, we're going to damage the threads. So we can put these nuts on here, and this allows us to get a pry bar in here to help resist the torque of us breaking the nut free, and we don't damage the threads. So what we're going to do, and because there's so much torque on this nut putting it in place, it's recommended to not put all that stress onto the gears inside of here. It's probably not a problem, but it's generally recommended to not do that. Cool. And then we'll get our nut on here, and when we break it free, the frame is going to stop the pry bar, and we should be able to break it free without putting any undue stress on our drivetrain. So we have a 30mm socket that slips on there. It feels a little loose, but I think that's the appropriate size. So we got a 30mm socket, and we got a big 1/2-inch breaker bar. Oh, yeah, baby. Okay, so we had a bit of an issue. When I took off that staked nut, it turns out that I did not unstake it as much as I should have. And in doing so, there was a lot of interference between part of this stake part of the nut and the end of my shaft. So unfortunately, the nut was really hard to get off, and then I ended up destroying the threads, the last couple threads on the end of the output shaft here. I mean, they were completely destroyed. So I got those last few threads filed down so that now my new nut engages the threads and it threads on perfectly. And with the flange installed, the nut still has most of these threads, like I want to say like 8 or 9 threads of engagement, which is more than enough. If I go back to my statics or dynamics classes trying to remember, something to the tune of like 90% of the load on the threads is taken up in the first like 4 or 5 threads. And we've got more than that engaged, so I'm not too concerned. Is it ideal? Absolutely not. I wish I wouldn't have done that. So take this as a learning moment. Make sure that when you are unstaking this nut, that you properly unstake it all the way. So once you break the nut free, if it's hard to turn the entire time, stop. and try to undo the staking a little bit more and see if that helps, because you don't want to end up in this boat. This sucks. All right, so here we have our flange, and then here's the seal. This is not the seal that I believe is leaking, but since we have it all apart, we're going to go ahead and replace this seal as well. The way we're going to remove it is actually from the inside. The seal overhangs, and we can actually catch the lip of it in here. So what we're going to do is we're going to take our brass drift, set this upside down, grab our hammer, and just lightly tap out the seal. Tacking it a little bit from each angle. There it goes. So there's our old seal. We'll want to do a visual inspection to make sure it matches the new one that we got. Don't want to install an incorrect seal. BG3657E, BG3657E. Cool. So we have the exact same seal. That is good. And again, just for your reference, that's part number 90312-23001. Go ahead and flip the flange back over. We're going to grab a fresh paper towel here. We're going to get inside where that seal goes. Make sure there's no grime, gunk, you name it. And that's looking pretty good. So when this seal was installed, it was perfectly flush with this surface here. It is possible to drive this seal in too far. So we want to make sure we don't do that. And what I'm going to do is we're going to get this seal started as best as we can by hand. And then we're going to use our brass drift to drive it in place. Or what we can also do is use an appropriately sized socket to drive it in place. But since I don't want to take it too far, if I use this brass drift, I can actually overhang the seal, so that way the brass drift will actually stop on this face and I won't drive the seal into. So that's what we're going to do. Make sure the seal is oriented in the correct way, so the side that's got the groove on it actually goes in. I'm going to get that centered as best as we can. Sort of just working it around just with my fingers before even using the drift, and I'm actually able to get it started pretty good. We will drive it home with the brass drift. So the name of the game here is not strength and beating it real hard. You just want to take it nice and slow, and we'll work our way around in a circle. Again, we are overhanging the seal so that way we don't drive it too deep. And get in there and feel with your fingers. So I can see we still got a little bit of a lip sticking up. Okay, that's looking pretty good to me. One seal done. Okay, so here are the new parts that we're going to need for this install. We've got the seal 90312-23001. That's going to be the seal that goes in your flange. So we've already installed that. And you've got your main seal for around the shaft. That's going to be part number 90311-41012. It's always good to do a double check. I actually had the wrong seal part number first. So you always want to make sure it matches up with what you took out. And then lastly, we've got the nut. Because that nut that was in there was staked, Toyota recommends that you actually replace that nut and that it's not reusable. So the part for that new nut, 90179-22016. It is time to install our new seal. And again, we're using part number 90311-41012. And I went down to the hardware store, or the auto parts store rather, to see if they had a seal driving kit that I could use, but unfortunately the only kits they had that would have worked were already being loaned out. So we're going to have to do just like we did with the smaller seal. We're going to have to try and tap it in, which is going to be a struggle because of this cross member here. So we're just going to have to take our time and make sure that we're making nice even hits and not driving it in cockeyed. I'm going to apply just a tiny coat of grease on the outside perimeter of the seal just to help it slide in smoothly, so we hopefully don't get any binding. And we're putting just a super thin film. So the seal will actually start on its own quite easily, which is nice. So I'll just press it in as much as I can with my fingers. Again, trying to stay true to it. You will know that you have the seal fully installed properly when the face, when this face of the seal is flush with the casing here. It is possible to drive the seal too far in, so be cautious. And when you're driving it, I like to overhang my drift, so that way it will contact the outer case here and I won't drive it in too deep. Alright, I'm pretty happy with that. Alright guys, we've got our companion flange ready to go. First, before I install it back onto the transfer case, we're actually going to apply a little bit of grease to the inside of this seal. And then we're also going to apply some grease to the outside of this sealing surface, just to help make sure we don't accidentally tear or rip anything when installing. It just helps everything slide together nicely. So just like before, we'll just get a little bit of this red and tacky on our finger, and we'll run it around. We'll grab our new nut, and again, I don't know if you can tell, but like I mentioned earlier, I did have to file this shaft down, but I still have probably 6 threads of full engagement. So I'm not overly concerned. Again, it's not ideal, but sometimes you gotta play the cards you're dealt. Alright, that's all the way. Okay, so now it's time to torque the nut for our companion flange. I did not see it listed in the Haynes manual, but in searching online, we need to torque this nut to 87 foot-pounds. And we're going to employ the same technique we did in removing the nut, by using a pry bar wedged between 2 of the studs on the companion flange with nuts installed so we don't damage the threads. And then I'm actually able to run my pry bar over to on top of my frame, and that way when I'm tightening it, the force goes into the frame. We have our torque wrench set to 87 foot-pounds. Alright, there we go. Go ahead and pop these nuts off. Now we have our nut torqued on, we need to stake the nut. So you'll want to rotate the flange around until you can see the indent for where the shaft allows room for you to stake it into. I've just got a square end punch here. We're just going to line it up and give it a few good whacks. Oh, didn't like that. That should be pretty good. We need to get our shaft installed back onto the companion flange. So first thing we need to do is find our companion marks that we made. So we should have one on our flange and one on the drive shaft. Here's the mark here. Swing my shaft around here and I'll spin it around. There it is. So now, press the shaft a little bit. Alright, and depending on how tight yours is, you might need to use a little bit of leverage. Let's try to get it extended back out. There we go. Easy peasy. So don't forget to use your lock washers. Nut. Lock washer. Nut. And then as with everything that's got a bolt pattern to it, I generally like to tighten it in a cross pattern. Go to our top one. It is kind of difficult to get in here with a torque wrench, so you might just have to make them good and tight. Again, that's 54 foot-pounds. Cool. That's one. And again, we'll cross over to the opposite side. Awesome. Two. Whoop. Alright, three. And the last one, I'm probably going to unlock the transfer case and rotate it around. There we go. Alright, that's all four of them torqued to 54 foot-pounds. I already put my Zerk fitting back in here. Next, we are going to top it off with some gear oil because we lost a little bit when removing the flange. Get this all cleaned up, get the skid plate cleaned up, slap it back on, and then we'll take it for a test drive and make sure it's we've actually fixed the leak. Alright, so we are done with that repair, and actually we've been done for probably a couple weeks now. I've already put a few hundred miles on the truck. I just wanted to make sure that I had it all actually fixed before I released the video showing you guys what to do. All in all, it's a pretty simple repair job. Nothing too complex. You just got to make sure you take your time. And as you saw, I did not unstake my nut properly and I paid the price. So like I said earlier, I don't have too great of concerns about any safety with that or anything. So I'm sending it, but do take this hopefully as a lesson that you don't have to learn yourself. Make sure you unstake the nuts properly. It's pretty important. And again, like I said, if it's difficult to remove the nut, once you break the nut free, it should spin right off. And if it's not doing that, stop. So again, as I mentioned before too, the same process really should apply to the rear output shaft as well. But Timmy the Toolman's got a pretty killer video on that. So again, check him out. He knows his stuff for sure. If you have any questions, feel free to drop them down below in the comments. Happy to answer whatever I can. And if you take it on, good luck. Take your time. It should work out just fine. Awesome, guys. I'll catch you on the next one.